I'm going to go through a hypothesis testing example that I have also provided the worksheet on Canvas in the hypothesis testing practice example. Hopefully you can open that, download it, and if you want you can print it and write on it, or you can look at it and do your work on a separate piece of paper, because the goal of this video is for us to walk through testing a hypothesis together so that you can kind of see how it goes while you're working through it with me. So you might notice I'm going through kind of slow because I'm actually calculating these things as we do this, and also explaining what I'm doing while I'm doing it and providing you tips that will help you on the exam to be successful and gain the most points you possibly can on the exam. So first and foremost, this is a one sample z-test because we're provided population information, even though it doesn't necessarily say population information. It says blood glucose levels for obese patients. So in my mind, it's suggesting that this is all obese patients because it doesn't say a sample of obese patients. So they have a mean of 100 and a standard deviation of 15. So those are our population parameters. So what I do is I just automatically write down the information I have. So mu equals 100 because that's the population mean notation, and standard deviation equals 15. So for population. So now we're going to look at some of the other information. So it says a researcher thinks that a diet high in raw cornstarch will have an effect on blood glucose levels. Don't let the word high throw you off and think that this is a one-tell test. You really have to understand what's going on and comprehend the sentence. Don't just look for trigger words because it doesn't necessarily mean because there's a word high that we're looking at a one-tell test, because it basically is saying that a diet high in raw cornstarch will have an effect on blood glucose levels. The word effect is vague, so that is suggesting a one-tell test. So they have a sample of 12 patients, so we know our sample size is 12. And we're going to look at using an alpha of 0.05. So basically, I always basically provide you the alternative hypothesis somewhere in the research scenario. So basically, you could say this entire sentence, a diet high in raw cornstarch will have an effect on blood glucose levels. That's the alternative hypothesis. But I basically regurgitate it again. Raw cornstarch will have an effect on blood glucose levels. So it's basically stated 2 different times in some sense. So the point of this is so that we can go through and do the 4 steps of hypothesis testing together. So we're using alpha 0.05. Oops, I need to change the color. Okay. So alpha 0.05, and we know it's a 2-tell test, right? So we can just make sure that we're accounting for it being 2-tell. So here's our sample of scores right here. So you're not given scores, you're going to have to calculate the scores. So the first thing that we want to do is work on step 1 before we start even calculating anything. The goal of this step-by-step process is to be able to state your hypotheses so it sets you up to be able to make a decision and state your decision appropriately. So it's important to go step by step in order. And I guarantee you, if I see like in your activities or things like that, anything, if I have where you have to do all 4 steps in one question, if I see that you did all your calculations and then you just threw in hypotheses, like as somewhere in the middle, it's going to have points taken off, because the first thing you should be doing ultimately is step 1, which is stating the hypotheses. So in this case, the null is basically the diet high in raw cornstarch will not have an effect. So the diet high in cornstarch will not, not have an effect on blood glucose. So it's important that we have the variables, both variables. So the diet and glucose, those are the 2 things going on. So the diet would be the independent variable, and then the blood glucose is the dependent variable. It's important you have those. So just saying there will be an effect on blood glucose, that's wrong, because what has an effect on it? So you need to make sure you're giving a complete null and alternative hypothesis. Your alternative is that diet high in cornstarch will, that's the key, have, we're just going to shorten this, will affect, how's that? Blood glucose. Boom. So this is will not, that's the null, and will affect is the alternative. So now we can move forward to step 2. So with step 2, bear with me, we're experiencing technical difficulty. Or slide 2, where we're going to go, oops, sorry about that. We're going to go to page 2. Maybe. Okay, page 2. So we're going to start step 2. Now, if you recall, step 2 is setting the criteria. Now, if you recall, alpha level is 0.05 and it's 2-tel, right? So we're using a 2-tel test. So one thing that I do that is helpful usually is I draw the distribution, and since how it's 2-tel, I'm going to put part of it there and part of it there. So basically we're going to split 0.05 in half. So 0.05 is 5% split in half. So we're going to put 0.025 here and this tail over here, 0.025, and then 0.025 over here. So we need to look up 0.025 in the unit normal table, and now we're looking in the tail. So that is column C. So you're going to look up 0.025 in column C, and you should be seeing, there's 0.0250, should be seeing 1.96 is the corresponding z-score. Okay? So basically right here is 1.96. Oops, all right. And right here is negative 1.96. So it's very important that you provide me both the lower boundary and the upper boundary when it's 2-tel. So for this answer, I would accept this if you want to draw the distribution, or if you just want to write z critical value equals positive or negative 1.96, or you could write Z critical value equals 1.96 to tell. So these are the acceptable things. So here's acceptable 1, acceptable 2, acceptable 3. 3 potential ways of doing it. So that's if it's a 2-tell test. If it was a 1-tell test, it would all be put into 1 tell, and you would either tell me whether it's a negative or a positive. Okay, so we completed step 2. We set our criteria. Did the distribution. So we had a z-score of way over here. Z equaled 9.54. And I don't know why I'm writing with that. It's not working very well. So Z equals 9.54. Okay? Way out here. Okay? Which corresponds to a p-value that is less than 0.00003. Okay? So we know that our test is significant if p is less than alpha, and in this case, so p of 0.00003 is much less than 0.05, so significant, and our absolute value of z, so I'm going to put that here, z, and I'm going to put the absolute value equals 9.54, and we're going to use absolute value because if it was a negative, it would throw you off, is larger than the absolute value of our z critical value, which is 1.96, right? So check, that's significant. So now we know we found significance. So we can actually repeat. Step 3 is to calculate our test statistic as well as any of the other statistics that coincide. So finding our p-value, calculating Cohen's d, etc. So remember, our population mean was 100. Standard deviation was 15. Our sample size is 12. So we're going to calculate the mean for our sample size. So to calculate our mean, we need the sum of x divided by sample size. Well, we have sample size, right? 12. So we just need to calculate that sum of x. So in your calculator, you can just, if you have a graphing calculator or a calculator that has a running list of numbers, this is a good time to really use that benefit. So 128 plus 115 plus 118 plus 139 plus 148 plus 157 plus 151 plus 130 plus 152 plus 144 plus 154 plus 160. Now before I hit enter, is what I do is I look through and make sure that I have all my numbers entered correctly and that there's no errors before I hit enter, because I can actually go back on my calculator and correct those errors. But as soon as I find out there's no errors, I hit enter, and my sum of x is 1696. Now, for those of you that do not have a calculator that gives you a long running list of numbers, so in the future we're going to be sometimes doing 15, 20 numbers, raw scores, and if your calculator will maybe only do show 5 numbers on the screen at a time, you might want to chunk the information. So you might want to take the first 5 numbers, add them up, and then write down the total of those 5 numbers. And then take this second set of 5 numbers, add them up, and write down that total, and then add those totals together. Just that way so that you can make sure that you're visually able, not missing any numbers, because when you only see a small section of numbers on your calculator, it's really easy to make a mistake and not be able to see the mistake. So that's just a little tip for you. So to get the mean, we're going to take the sum of x, this 1,696, and divide it by 12. And our sample mean is 141.33, because it's 33 continued, and we round to that second decimal, looking at the third number to see whether we keep it the same or increase it. So now we can go ahead and start calculating our z-test. Now remember, our z-test is the sample mean minus the population mean divided by the standard error of the mean. Okay? Well, the standard error of the mean, so we have m minus mu, is actually the population standard deviation divided by the square root of the sample size. So this is all 1 and this is all 1. So if you plug into your calculator all at once, make sure there's parentheses around that. So ultimately, we're looking at 141.33, sorry, that was messy, minus 100 divided by 15 divided by square root of 12. So again, if you're putting it all in your calculator, put parentheses in there so that it keeps the order appropriate. So 141 is what I do is parenthesis 141.33 minus 100, close my parenthesis, divided by, and then I do another parenthesis, 15 divided by square root of 12, and then I close my parenthesis. And we got 9.54. Now this is extremely high, extremely high. So I am actually glad that we have this, because it gives you, I'm sorry about that, gives you an idea of how to deal with an obtained test statistic that is higher than what your tables show. So if you notice your unit normal table, and I'm sorry about my phone ringing in the middle of this. Luckily it wasn't my dogs barking. But your unit normal table, the highest z-score is 4. Okay? So we can just use that. So we're going to look at the tail, and we're going to see the probability at 4. And you'll notice in your unit normal table, it's 0.00003. Well, we know that as you get further out in the tails, the proportions are smaller, or the probabilities are smaller and smaller and smaller. So if 9.54 falls further out in the tail than 4, which it does, we know that our p-value is going to be less than 0.00003. So basically, that's what we're going to report. P is less than 0.00003, because that kind of tells us we didn't have an exact number, but we know it's less than this number, and that's perfectly fine, because that's well below 0.05. So the next thing we're going to do, so we have our test statistic. That's our test statistic. We have our p-value. Now we want to calculate our Cohen's d to be able to determine, how many standard deviations did the high cornstarch diet actually affect the blood glucose levels in standard deviations. So the equation is the mean minus mu, the sample mean minus population mean, divided by the population standard deviation. You basically already know this equation. So we have 141.33 minus 100. So we know the difference between those is 41.33 divided by 15. Okay? So 41.33 divided by 15 is 2.76. That is a large Cohen's d. What that's telling us is that eating a diet high in raw cornstarch shifted the sample mean by 2.76 standard deviations as far as their blood glucose levels, and that's a lot. So that's a big shift. So now in step 4, we need to determine whether there's significance. So let's look at, really quick, we're going to look at our z-score. Oops, I don't know why it's black, but our z-score and our p-value, okay? So that we can determine whether it's significant so we know how to write our results. So let's go back to slide 1, results. So to report your results for step 4, they must be an APA. And this is literally the largest points on any exam, on labs, anything that you do. The APA format is the high points. So basically, you could do all of your calculations perfect and then get to your APA statement. If you can't communicate your results in the language that is necessary for research, then your math is meaningless. So that's where you have to realize this is beyond a math class. This is being able to take your math and communicate it to the rest of the world in a standard method, in a standard way. So that APA format is for a reason. So since we found significance, we can just regurgitate our alternative hypothesis. And that's kind of my standard. If I find significance, I regurgitate the alternative and turn it into a past tense. If I don't find significance, I regurgitate my null and turn it into a past tense, and then include the statistic information in the right format. So I'm going to put diet high in cornstarch significantly increased blood glucose levels. Oops. So when it is significant, I always put how it was significant. Did it increase or did it decrease? Because that's really gonna, that makes it sound much more, impactful than if I just said diet high in cornstarch significantly affected blood glucose levels. Well, effect is kind of weak. When we're reporting this kind of research, we want to be like, well, it affected blood glucose, but that could be anything. It increased blood glucose levels, so it's very meaningful. And as Z equals 9.54 is what our Z was, P was less than 0.00003, alpha equaled 0.05 to tell, with Cohen's d equaling, I'm trying to remember what that was, bear with me, 2.76. Okay, this is all one sentence. All of this is one sentence. So it's not a sentence and then a period after this, and then you report all your statistics. No, it's not. I'm taking that period out. It is all one sentence. You start with your test statistic and you follow up with your p-value, because the p-value is the probability value at a location of 9.54. They go together. And then you want to report your alpha level after your p-value, because that's what you're comparing, alpha and p, and you're going to report whether it's one tail or two tail, and then follow up with your effect size. Whether or not things are significant, you report an effect size. So that's the APA format, and it's just a matter of coming up with a way to remind yourself of how it goes. So maybe Z, P, A, direction, and effect size. Like if you come up with some acronym or something, it might help you to remember that order. But remember that you have to have your statement there too, with both variables and whether there was an effect or an increase or a decrease. So hopefully that helped you walking through that with me. A little bonus is that at the end of this video, I'm letting you know that if you email me your work from walking through this video with me, you can get some extra credit points. So clearly those of you that have walked through this and done this, you're the only ones that will know about this. So it's a little bonus extra credit and a little hint to you. For those people that don't watch these resources, they don't get these little bonus extra credits. So send that to me via email and you'll get some extra credit points. Hopefully this video helped.